Today on the Tech Bytes podcast, sponsored by Nokia, we hear from Nokia customer NLIX. NLIX is a leading internet exchange based in the Netherlands. The organization recently redesigned and upgraded its network. Nokia played a role in that upgrade, including 400 and 800 gig routers and its FP5 silicon. We're joined by Dirk Kalkman, Chief Network Architect at NLIX, to talk about what drove their choice of Nokia, including performance and power efficiency, how Nokia is helping the IX deal with DDoS, and more. Dirk, welcome to the podcast. Can you give us a little background on NLIX, and then let's get into what drove the redesign?
Well, NLIX is one of the larger IXs in Europe, and we're the one that does it different than everybody else. We're the lunatics that thought it was a great idea to stretch an entire VLAN over the European continent.
Oh, wow.
Yeah, so you can pair from Marseille to somebody in Copenhagen, and that's all. That's all okay.
Hey, routing is for people with no guts, no glory.
Yeah, so layer 2 is the way to go, but it's a challenge and a fun one at that. And it gives us a little bit of an edge. Expanding our network is much easier to do that. So when I came to the company about 5 years ago, we were still running the old switches, the Brocade MLX series, tried the Extreme SLX. But that was a horrible story for every exchange in the world that tried that machine.
Well, it was state of the art at the time, but I think the story really is the world moved on, right?
Well, the SLX was a little bit over-designed, right? So it could probably, if I would ask the guys from Extreme to make it a cup of coffee for me, they would probably program it in it. So it could do everything except what it needed to do, and it crashed the entire MPLS fabric, right? So it was a little bit of a horrible story. But we needed more power. The MLX 32 we had at the time was 64 times 100G in a full rack, so that's not scalable. So we went with to the major vendors, and we didn't choose Nokia at first. What most people don't know about NLIX, and that's a fun little fact, is that we actually run two networks. We have an A and B fabric. And that's especially for the enterprise. So completely separate vendor separation. And we actually had the great idea to put Nokia at the B fabric and put a different vendor at A fabric. So that choice was made, and we deployed the big machines of the vendor for A fabric. I will not call it by name because I still want to have a good relations with them. But
it didn't work. I'm guessing it didn't work out. So that's an interesting one. So you went multi-vendor. It sounds to me like you went multi-vendor so that, if you had a problem with one, you could rely on the other and, have a multi-vendor strategy and that sort of thing. But the flip side of this is you didn't have to go all in on one vendor. You had a rollout, a way to migrate. So the vendor A failed, but vendor B was there. So you kind of won.
So when vendor A AOL'd my network, we were really disappointed because we could only buy 1 and 10G line cards for our new shiny core that was supposed to be designed for 50 kilowatts. And the design was actually to go to 400 and 800G, where 800G was not announced officially, but was on the promise list. Mm-hmm. But we were already talking with Nokia. So we called Nokia, said we had a major problem, and we wanted to switch over. So push the vendor for Fabric A back to Fabric B and push Nokia to the A Fabric. So Nokia delivered, and they delivered very well.
So there's an interesting thing in there. You're talking about power. You were saying that, Nokia was able to give you 10 gig, 100 gig, 400 gig, and 800 gig, and stay within this 50 kilowatt budget. And that's a major concern for you. That's not something we hear talked about much until recently.
If you look at our power consumption, it stays the same, but the amount of traffic goes up. So the power per gigabit goes down. And it's a massive amount of power, right? Because, and it's not just supplying the power that's the problem. The problem is cooling it. So we have about 50 kilowatts on a single rack, powered by 20 times 32 amp. And when you go to data centers with that power requirement, you get the difficult people at your desk, and they want to do heat calculations and other stuff. because they cannot cool it.
You actually end up buying 10 racks of space because it takes...
For
you're
example,
using 10 racks worth of cooling or something like that, whatever.
Even more, because we went to the data center. We said we want about 60 kilowatt because we need a little bit more for supporting services, but we want 60 kilowatt. How many racks can we get? So we actually got 24 racks just to cool it. And I only need about 6 or 7, right? Wow. So
yeah, you've got this big open space with 6 racks in the middle, and that's literally because the cooling is only. Yeah, that's very common. So what you're saying there to me is that Nokia is really focused on the power consumption angle, and that's a concern for you, but increasingly a concern for other people. Because like when you're burning 50 kilowatts an hour or 50 kilowatts you're actually talking about real money. Like routers, you just draw power. Like your power bill is something, is what I'm trying.
Power in the data center isn't cheap. It's a lot of money. So if you want to do that and you want to grow, you have to look at your power consumption and overall, not just your router, but also your transport, your supporting services. Everything is important. The machines we have now can support about 216 terabits within that 50 kilowatts.
So how do you do that? What is special about Nokia technology that makes that possible compared to some of the other suppliers?
It was the main focus of their FP5. So their chip design was mainly focused on power reduction. So that makes it very efficient. So that helps us.
But it's a very modern chip, but it's also huge.
Yeah.
So whereas before you would have to have 2 or 3 or 4 boxes to get the same capacity, now you can do it in one.
Yeah, but it's a big one, right? We have the 14S systems, so it's a full rack, 12 line cards. But it's mainly due to port capacity. We try to, and that's one of the parts of the efficiency design. We try to connect as much customers to a single box as possible. For the simple reason, if I can handle traffic within the same machine, it's cheaper and more efficient. As soon as I have to transport to a different location, it's going to cost me money and it's going to cost power. So that's why we also chose for just 3 core locations within Amsterdam. I can serve almost any customer within Amsterdam with 800G and just have it a single hop away. So it's almost just one hop that I have to transport it. So that makes it that's also part of the efficiency design.
Right. I want to ask a question about software quality because a lot of customers may never have heard of Nokia as a router vendor. Right now, no disrespect, Nokia has done it for decades. They've been providing it to telcos, but as an IXP, the software quality has met your expectations.
Yeah, it's a different beast altogether. If you're used to Brocade, you're used to, for example, Juniper or Cisco. CLI of the other vendors is much easier, but as soon as you understand the logic Nokia has put in their software, it's very easy to understand. But it's very much based on control. But that's also the history of the telecom operators, right? They want to be predictable. So the software reacts in a very predictable way.
Okay, I want to go back to this power reductions because in the show notes, we've got some numbers here. You're talking about moving to the deployment of Nokia routers using the FP5 silicon, and you went from 0.8 watts per gigabit to 0.1 watts per gigabit. I assume that 0.8 was the extreme gear from the AMLX stuff down to 0.1. That is a lot of reduction. So that basically means you've got room to grow. So that data center that used to be like full capacity is now probably 20% capacity now, something like that.
We're currently at about, the machine is currently running about 12 kilowatts. So we're not even,
Was 50, is now 12.
Yeah, and we moved every 100G port to that machine. So the amount of connections on it, we are currently running about 200 connections on it. So that's not bad.
I wanted to ask about critical national infrastructure. Internet exchange points are now regarded as critical infrastructure.
Not everybody.
does Nokia fit that model? Like, did you have to go through the
Yeah, of
hoops to
course.
get it approved, or was it just?
No, that was a check in the box. Because Nokia runs all the telecom operators. They already know with this. But actually, we're marked as vital infrastructure by the government. But that doesn't mean they actually have a say in what kind of equipment we run. It's
Right.
more compliancy and certification. You need to have emergency processes. You need to have your business continuity in order. More that kind of stuff. Then you have
like
to run vendor A,
process.
vendor B. You're not allowed to run vendor C. That's not applicable to us.
Right, okay.
So you mentioned Nokia. One of the reasons you looked at them was the power efficiency, but you also mentioned 800 gig. Is 800 gig something that you're using just for specialized deployments or something that you're using more widely?
It's not as much for the 800 gig per se. It's more the statement of technology. To achieve 800 gig, you need to have the 112 gig SerDes, and it just means you're ready for the future.
I see.
It means my box can run for coming 10 years.
Okay, so you were looking out longer, saying I have the capacity to get up to 800 gig if I need it.
Yeah. And I do have a few crazy customers that want the 800 gig. And it is also a talking point somewhere about the anti-DDoS. So we do deploy 800 gig, but commercial requests is still 0. 400 gig. Yeah, for 800 gig, we don't see it. We don't see customers supporting it yet, and most customers stick with the 400.
But the point is that you're going at 400 now because that's doable. 800 gig is here, the equipment exists, but that doesn't mean that it won't be requested in the next 12 months, 2 years, 5 years. And that's the life cycle of the gear, right? If you bought gear that only did 400 gig, you'd be caught out.
Yeah, and the standard for 800 gig Ethernet was lacking a little bit. So the pluggables are now coming. It's more and more now being pushed as something that's more standardized.
So you just made an interesting comment there about DDoS, and I mean, it's obviously a real thing.
Yeah.
I never thought IXPs did anything about it, or do you?
We assist. Right. We have multiple scrubbing services connected with clean pipes to our network. So you can get a clean pipe to multiple scrubbers of your choice. That helps. We are working with Nokia to deploy technology that can actually do more. It's still a little bit on the development, and I don't want to share too much of it. It's one of the reasons why we chose the FP5. Their eChip has a massive filter capability, and we're seeing if we can unleash that onto the exchange. So that would be very interesting.
What you're alluding to there is you're going to start putting filter lists in there for known bad, which is not normal. Like when you're in an IXP, normally you just want to let the packets go. Right? You just want to let the packets go wild, right? And you don't want to get involved because that's someone else's problem, right? And when you talk about DDoS providers, having clean connections in, that's so that companies who are connected to the IXP can invoke those providers. Right.
You can your clean pipe. You can put your prefix to it if you have a subscription there, and they filter it. They attract the traffic, and you just get the clean traffic through your clean pipe.
Yeah, that's right.
But it sounds like what you're saying is similar to 800 gig. You see this FP5 platform as giving you options in the future if and when you need them.
Absolutely.
You're not going to do the DDoS, but there is a bunch of filtering that you could do to stop like basic stuff like bogons and stuff. Why?
Actually, we do the DDoS, but that's more of a testing subject. I'm involved with a government, a collaboration. That's the Anti-DDoS Coalition. And we actually once a year test the government infrastructure with on production environment with real life DDoSes, and NLEX is involved there to just transport it. But it's a massive amount of DDoS traffic. So we actually run into the terabits of DDoS traffic and see what happens.
Wow.
So that's a very interesting subject. You can talk about it for hours.
Yeah, you could, and it sounds a bit like it's a bit early and it's a bit confidential at this point as well. One of the things that we also talked about was you're not just doing IP routing, you're also doing optical transport for DCI. Does the Nokia support the DCI stuff, like to provide those overlays to provide L2 connectivity end to end?
Nokia won. They won our RFP for optical supplier. That's how we got to know them. Actually, it's one of the first contacts that I had with Nokia. Yes, they can do all the kind of optical transport you want. But the funny thing is, actually, when we started with Nokia, it was focused on the optical part. But actually, we ended up buying more IP equipment from them than optical equipment.
The optical stuff isn't as much as you think, especially now when you're in the era of putting coherent pluggables into the IP equipment, right?
Exactly.
So instead of the old days where you had like a DWDM switch and then you had a DWDM edge, which had an optical to an Ethernet, nowadays you can just plug a coherent pluggable straight into that Nokia. And boom, that's your DWDM edge. And that changes the game substantially, like in terms of equipment, much less.
And in terms of power. So the amount of power you save by that, by just scrapping multiple boxes from your network, that's massive. And not only power, but also your management infrastructure, the amount of knowledge your operators need to manage an PSI or a PSS system. It saves a lot. Yeah, absolutely.
It also gives you one throat to choke, because if you're using coherent pluggables from Nokia in Nokia routers connected to Nokia, optical DWDM gear, then all of a sudden, support gets a little easier, or at least a little more focused, shall we say.
I must say Nokia is not the difficult one in that one. So if you have a third-party pluggable in it, your support case does not get rejected instantly. But yeah, for the coherent, we're going to choose the Nokia pluggables. And we're actually going to test it out between Frankfurt and Amsterdam. That's one of our first test subjects to do this. We're currently running 2.4 terabits between those two locations. So it's one of the best sites to choose if that's going to work. It's about a distance of 800 kilometers.
Yeah. Well, Dirk, we've come to the end of our time. I think there's probably a lot more we could talk about, particularly around 800 gig and DDoS, but maybe we can have you back another day. Are you on LinkedIn if folks want to find you and follow you online?
I am on LinkedIn.
Okay, great. That's Dirk Kalkman. And we'll also have that link in the show notes that accompany this podcast, as well as links from Nokia if you want to find out more about what they're up to. But that does wrap up our show. Thank you, Dirk, for joining us. And thanks to Nokia for being a sponsor. Sponsorship ensures that Packet Pushers can bring you free, high-quality technical podcasts, videos, and more. Speaking of which, you can find this and many more fine free podcasts and our community blog at packetpushers.net. We've also got videos on the YouTube channel, the Packet Pushers YouTube channel. You can also follow us on LinkedIn, hear us on Spotify, and if you would, leave us a rating on Apple Podcasts. And last but not least, remember that too much networking would never be enough.